Good morning, everyone. Today I am taking a lecture real as a design and technology. In that, we are having studying the first chapter, unit 1, design flow. In that, I explained about what types of modeling, otherwise styles of modeling in VHDL. There are 4 different styles of modeling in the VHDL. First one is data flow modeling. Next one is behavioral modeling. Behavioral modeling. Third one is structural modeling. Fourth one is mixed modeling. These are the 4 types of what styles of modeling in the VHDL. So I have started with what data flow modeling in the previous lecture. So it is a concurrent statement. It contains what? Concurrent mode. It is a concurrent statement. It contains concurrent statement. It is called as concurrent mode. And what about this behavior means? It is a sequential statement. Sequential mode. What is concurrent? At a time, statements, the codes you are using, you are executing at a time. What about the sequential means? One by one you are going in a VHDL. So there are 4 styles of modeling in VHDL. Actually, I explained to you in the last previous lecture. Just I am repeating once again to recall. I am just recalling everything. First one is data flow modeling, behavioral modeling, structural modeling, and mixed modeling. Okay. So in the data flow modeling, I told you that it is a concurrent and it is a sequential behavioral one. So I have started with what data flow modeling. In that we are having 2 types, which are 2 types or 2 different. And even I explained about what? I explained about data operators. Right. Data operators in the. I'm just now I'm explaining only on data flow modeling. It contains concurrent statements. Current is a concurrent mode. In that one, I explained about what? Data operators, for the shift operator, for the logical operators, for arithmetic operators, you are different. You are having different operators in the VHDL for the data flow modeling. Just we are what we are doing what divisions, we are doing what separations for the models depends on the modes. Maybe data flow, behavioral, structure, and these are the different styles of modeling. So in that I have explained about what data operators and also when statement. So in this one you are what you are using the when statement. In the when statement you are having we are having 2 forms when select. Stop meeting. सर आपल्या दोघींना बोलवलं मला फोन आला मगाशी मी म्हटलं लेक्चर झालं होतं we are having when select and with select when. So I explained about this when select and now I will go forward with select when. I have taken a multiplexer example to explain this when select. It is a simple format. So next one is with select when. So what I am explaining now is data flow modeling. In that one I am using what? There are 2 forms in the data flow modeling. When select and with when select. These are the 2 forms. In that I explained about when select by taking the multiplexer as an example. So now I will start with what? With select when. So I will take, I explained about what? Multiplexer. It is having A, B, C, entity is the input, Y as the output, and S1 and S1 as the selection lines. So, about this I explained previously only. So, going for 0, 0, 0, 1, 1, 0, 1, 1 for the different selection lines S1 and the S1. So, according to that, we are having different outputs. That I explained you when I was explaining about what when select. So, I will start with select when. This is the second form in the data flow modeling. So, first one, I will start with the, so it is a programming language. So, while explaining this PHP, it is having what? 3 sections: library section, entity, and the architecture. Library, it is having 2 lines. First, that library IEEE use IEEE standard logic 1164.org. Okay. Next, so it completes what? Library section. Now is entity. So in the entity, what we are having? We are having inputs and the output. Entity is. So port. The port what we are having? Only inputs and outputs at the entity. What are the inputs? A, B, C, D, right? A, B, C, D. In logic, in standard logic. Okay. And what about the select? It is in standard logic vector. It is in standard. One down to 0. Next is Y out standard logic. So this is the this is the more entity part. I explained it previously. Only it is having 3 sections: library, entity, and the architecture. In the library, you are having what? You are using 2 lines. One is library and the use. I explained you about this many times. So we are using library for the different procedures, for different functions, for different applications, for different operators. We are having different. We have saved everything in this library according to your requirement. You are getting, you are taking, you are retrieving the data from the library. So this is what first section. The next section, what we are having only inputs and the outputs. There is no design, there is no structural design in the second part, it is entity part. So in that one, entity mux is part support A, B, C, D are the C. When I am having the mux multiplexer here, A, B, C, D as the inputs, Y as the outputs, S1 and S1 are the what? Selection lines. Okay. So this one I have explained many times. The multiplexer is simple. If you check the previous lecture, you will understand what is multiplexer. Okay. So taking the same example, I am having what? Inputs as A, B, C, D in standard logic. We are having 2 selection lines, S0 and the S1. So it is in standard logic vector. It is having what? S0 and S1. So only it is 1 down to 0. Next, what is output? It is out standard logic. Next is what? End of the multiplexer. Entity name is what? Mux. So only end of the mux. So what we will do next? Next section is what? Library over, entity over. Next is architecture. So we start with the architecture with this form, with the select event. Okay. So architecture. So I'm changing. You need to change the different names for what? This entity and the architecture. Architecture mux to of mux is, it is architecture name, it is entity name. So will start with what? Begin. We will start with what? Begin. Next, what we will having? We are having now. We will what we are writing? Architecture. We will write what? Design here. So, which one form? This form. With select SELECT. Select. So about this declaration, I explained in the previous lecture only. We were having what syntax. First I will tell. First I will write the syntax for this. Then you can understand easily. So with identifier. See now I am writing with select one syntax. Identifier select. And assignment when value assignment value. See, this is the syntax. So it is everything is same as previous one because we are having three sections: library, entity, and the architecture. Same thing for library, same thing for entity because we are using mux as the example. So there is no need, there is no change still here. When you start with the architecture, what you have taken? You have taken the architecture name as mux2. There should be different name. The name you should take it as different. Here is mux for the entity name, mux2 for the architecture name of mux is start with the begin. So here there is a change. So what is that is we are using with select when. For that there is a syntax here. With what is the syntax? With identifier select. So what I wrote here? With which identifier it is? It is a select. Okay. If you are writing some program, it depends on syntax only. So same thing. With as it is, select as it is, but identifier it is a select. Okay. Next. In the mux, I told you now. In the mux, what I told you is S0, S1. So for that you are having what different combinations? 0, 0, 0, 1, 1, 0, 1, 1. So I may take it as Y as A, B, C, D. What will be A when select line is 0, 0, 0, 1 is B, 1, 0 is C, 1, 1 is D. Okay, so that one we have to write in this form. With select. Which form? With select one. Okay. With select with identifier select. Okay. It's over. Next line is assignment when value. So which assignment is that? Output will be A when just try to A when it is 0, 0. Okay. B when it is 0, 1. C when it is 1, 0. D when it is others, other than this all things. Other than all these things is nothing but what? 1, 1. So next end of the mux 2. I think you understand this. See what I'm telling now is with the selective when that syntax is here. So we are taking what multiplexer as an example. In the previous I explained about what with select. Now I will say with name when select. Now it is with select when. For that you are having what syntax here. So you have to what follow this procedure. Everything is same till here. There is a difference in this is that you have to go through this syntax with select. Here identifier is SEN select. Okay. Next is y greater than equal to means it is showing the output. A when it is 0 0, B it is 0 1, C it is 1 0 and D is others. This is the end of the mux 2. So this is what in the data flow modeling I have explained about second form that is with the select when. So we'll go forward next one. So this is the what just now still we are what studying about data flow modeling only. Data flow modeling using generate statement. Generate statement. So what we are doing now? Data flow modeling using with when select when with select when is over. Now we'll go for what generate statement that is in the data flow modeling. Data flow modeling what concurrent statements, concurrent coding, concurrent mode. So it is a concurrent statement. So for that, it is like somewhere it is like sequential. How means we are having two formats for generate. Next one is for generate nested inside for generate. For generate. So first one will go for what? Generate. What we are studying? Data flow modeling using the generate statement. In that one, I will just explain about what? Syntax. Okay. Syntax is, see if you know the syntax, then only you can write the program. Label or identifier in the range generate. This is a concurrent assignment. And generate. So what is this? It is a syntax for generated. And next one is for generated nested inside for generated. So that what is that means? So it is not for sorry. It is if generated. See, if means we are having two options. If it is this, otherwise it is like this. So if generate nested inside the for generate. So we are what we have said here for generate you are having a single label. So end of the generate is over in the syntax. But for the if generate, it was for generate, but it is if generate nested inside the for generate. So you are having what here in the syntax we are having two labels. Label 1. Are you understanding? It is just a syntax. Label 1 for identifier in the range generate, generate. Label 2, if condition, generate. Concurrent assignment is what? I'm writing it is in what? Bracket. Concurrent statements. And generate. And generate. See, in this one, what we are studying here is for generate is over. For this one, you are having a single label for identifying the in-range generate. It is a concurrent assignment, so it is an end of the generate. But in the next one is it is having if generate and the for generate. If is inside the if, this is inside the if. Are you understanding? If generate is nested inside the for generate. So this is for what? Generate statement. First thing is over. The second thing is what? It is there inside the if generate. So you are having two labels for that. For identify in range generate, if condition generate. Label one is what? For identifying. Label one is for identify in range generate. For the label 2, it is going for what? If. First one is this, second one is this. If condition generate, if you are having some condition, if it is 0, 0, then it is like this. If it is 0, 1, then it is like this. Same thing. If it is for the label 2, so it is the end of this sentence, end of this sentence. This is the state. This is the what? Syntax for the generate statement. Next one is what? Block statement. Next one is what? Block statement. So it is what? These all are the concurrent statement. What I explained now, the data flow modeling. First one is what? When select, it select, when select or it select when. That is over. Next is generate. Next is a block statement. Data flow modeling for the data flow modeling for the block statement. What is the meaning of block statement? It is used for what? Partitioning. Put in mind. Block means what? Partitioning. What is partitioning? If we are having a code, it's too lengthy, and just what I am doing? Partitioning. Just cutting. But it will be the same thing. But for my purpose, what I am doing? I am cutting, I am separating. That is partitioning. It is called as a block statement. So block statement, if you want to do, means what it is just clusterization. If you are having this one as a length of program, you are having, you are using what? Separating, you are doing the partitioning by using which statement you are using? There you are using block statement. The syntax, do you understand? Block statement is what? Just for the partition. That's it. Simple statement, simple sentence. It is for what? Partitioning. The syntax for this is label, block, declarative part, and declarative. If you don't have declarative part, it will go for what? Begin part. Declarative part. So otherwise it is, even if you are having, if you are doing any declaration about the anything constant, whatever, it will declare the part. Next we start with the begin. Concurrent statement. You know it is concurrent only for the data flow model. Concurrent statement. End of the block model. I think you understood this. Simple thing is label, which is labeled this block. Why they are using for the partitioning. Declarative part is there. If you don't have any declarative part, then you go directly to the begin thing. You are having concurrent statements, then with the end of the block model. Just it is a partitioning. So if I'm taking an example, there is no way to explain the example for this. Just simple thing how to do. Okay. How to write this means what? Architecture. Just I am writing as the architecture because I will telling you how the design will be. If you know that library and the editing will be same. Means what? Same as previous. Library depends on the your requirements and editing depends on what input and the output. So just I am going to what architecture now. So architecture example is what? Begin. Okay. Block 1. Block 1. Block. Next is begin. What I'm doing this just to I'm not observe carefully. End the block. Block 1. Block 2. Block. If you are observe carefully, you will understand. It is very simple. End of the block. Then end of the example. See what we are having here. Just I am going there to the architecture. What we are studying is the block statement. It is for the partitioning. Just we are dividing. That is the what work. That is the function of the block statement. So begin. You know when the architecture inside what begin. Architecture name is example. I'm taking here. Okay. Architecture example. Start with the begin. If we are having a declaration, we can write the declaration part. There is nothing, we will go for directly to the begin. Block 1. See here, is a block 1 is block. Begin. End of the block 1. See, I am just writing syntax. There is no here any example. Just I am taking how the flow will be. So block 1 block. It is begin, then it will end up the block 1. Means this section is over. Partitioning is there, na? So block 2 block begin, end of the block 2. It will go for next thing, block 3. For the block begin, then end of the block 3. Next, block 4 block begin, end of the block 4. Same thing will repeat. We just do the partitioning, then finally we come to the end of this example. So this is the what block statement. It is how the architecture will be. I explain now. Block means what? Just the partitioning. So what? Next thing is simple thing. Now next point is guarded block. So what we have studied with select event. So data flow modeling, there are two forms block. Which one? First one, when select with select event, and second one is what? Generate statement I explained. Next one is block statement. Now it is guarded block. What is guard? What is block actually? Separation, partitioning. See, simple thing. Block is for the partitioning. In the guarded block, it will execute this guarded block when the guarded statement is true. When the guarded statement is true, then only it will execute. So that is the guarded block. This is a block statement. There is an additional one is called as guarded. It will be executed when the guarded statement is true. So then now what I will explain, it is a syntax. Guarded block, so label, block, guard expression, is declarative part. Begin. The same thing here, same as a block, but the difference is that if the guard is true, then it will execute. Otherwise, it will not execute. Then there is no separation. So declarative part, begin, concurrent, guarded, and unguarded statement. And block label. So it is same as block, but the it will execute when the guarded statement is true. So it is an additional statement. Additional thing is that guarded. It is label, block the guarded expression. It is started with the begin, means it is end of the block label. Same thing is there. There is no difference. The thing here is as guarded block. When guarded is right, when it is true, then it will execute. So what we have studied now, still we are completing our data flow modeling. Data flow modeling, I explained different statements. So next style is we will come towards what we will go forward in the next lecture. Okay. So styles of modeling, then I explain about data flow modeling. If you are having any doubts, you can ask me anytime.